Assalamu alaikum. The sign test is perhaps one of the simplest statistical tests. It is simple because the type of data used can be even categorical, like more, less, better, good. And of course, it can be interval or ratio type of data as well. The data does not have to be normally distributed. It's also simple because the calculations are straightforward and usually you don't need software to execute it. But it has its own limitations and that will be discussed. The sign test is a non-parametric test. The more powerful parametric tests require that the data be continuous and the data be normally distributed so that only few parameters can characterize the set of data like the mean, the standard deviation, and the total number of observations in each set. And by the use of these few parameters, the parametric tests can be performed. On the other hand, the non-parametric tests are distribution-free. It can be carried out on sets of data that are not normally distributed. And the type of data can be anything from the ordinal to the interval to the ratio scale, so long as you have 5 or more observations in each set. It can be carried out on categorical data like more, less, better, good, very good. And that's why it is simpler, but it has limitations. The sign test is one of the non-parametric tests. It depends on having two sets of paired observations. The data should be paired or related, like pre-operative and post-operative, or like differences between different observers or different tests on the same thing or the same subject itself. In this presentation, we shall go through the sign test. In later presentations, we'll take the other two basic non-parametric tests. The first example here, we are running a trial, for example, to see if there is a better way of doing tonsillectomy. So we had one tonsil removed by the standard technique and the other tonsil removed by the new technique in the same patient. And we had 9 patients enrolled for the study. And after 10 days or 2 weeks, we compare the healing between the two tonsils and we grade it whether it is good or very good or excellent or moderate. So we end up with two sets of data, the tonsils that have been removed by the standard technique and the tonsils that have been removed by the new technique. Notice that the two sets are paired. Each patient had the two techniques, one with the standard and one with the new. With the standard technique for patient number 1, the results were good, but the results with the new technique were very good, so we put a positive sign here. In the second patient, both were good, so we put a 0. There is no difference. In the third patient, the result of the standard technique were better than the new technique, so we put a negative. And we go on with the 9 cases and end up having some who have a better healing with the new technique or no difference, or a better healing with the standard technique. Then we count up the number of the positives, it is 6, and the number of the negatives, it is 2, and the number who have equal, it is 0, would just be omitted. So the total number of patients are now 8 rather than 9 because we have deleted the results where there is no difference. And that's about it. Now we have 6 positives and 2 negatives, and the test statistic, the sign, is the lower of the two. So the test statistic here, the S equal 2. And the number of the cases are 8. And what we need now is to check whether this small number is statistically significant or not, the difference between the 6 positives and the two negatives is statistically significant or not. Now, these two related sets of data can be observations on the same patient before or after a certain treatment, or it can be repeated measures on the same patient, or it can be two different tests carried out on the same patients, like examining a tumor by, for example, an ultrasound, or examining the size of the tumor in the second group by an MRI scan or pathology. Or it can be different observers, for example, grading the mark of students, observer number 1 and observer number 2, and we'll try to see the difference between the two. Now, to find out whether the results we obtained are statistically significant or not, the S value equal to, is that significant or not significant, we need to use certain tables for critical level of significance. These tables are based on two important factors. One of them is whether the trial was one or two-tailed trial. In a one-tailed trial, you are pretty sure that one of the techniques is better than the other, and you want to prove it. And the two-tailed trial, you want to explore whether actually the new technique is better or worse than the standard technique. That was the case in this imaginary trial, so we are using a two-tailed trial. The second thing is the p-value, the alpha value. In medicine, it's usually less than 5%. So here the alpha value is 0.05. And by the use of these tables, after setting the two things, you need to set out one-tailed or two-tailed and the level of significance. You go through the number of observations in the trial, and you find out a critical level, and your result should be equal to or less than the critical level. So in our trial, we had 8 patients. Remember, we had 9, but one of them was deleted because there was no difference. And we have a two-tailed trial with alpha value of 0.05. The critical value here is 0. That is to say, in order to prove that the new technique is better than the old technique, all the results should be positive. The lower of the two results, of the two signs, should be 0. There should be 0 negative results. All the results should be positive. Obviously, this is not the case, so the results of the trial are not significant. We cannot prove that the new technique is better than the old standard technique, although there is a good difference. 6 cases were better than the other 2. And this is one of the limitations of the sign test. It has a low power. It has a high type 2 error. It can have false negative. The new technique may actually be better than the standard technique, but we are not able to prove it because of the low power. We cannot see the statistical difference between the two sets of data. The other limitation is that the sign test does not account for the magnitude of the difference between the two pairs. Some of the results were excellent compared to, for example, moderate, and some of the results were good compared to very good, but the magnitude of the difference are not accounted for. What is relevant in the sign test is whether there is a difference, positive or negative, regardless of the magnitude of how much better. Just, is it better or is it worse? And this example will show this more clearly. Here we are running another imaginary trial where 2 examiners are examining the same student at the same time and giving them different scores, examiner A and examiner B, for 10 different students. And as you can see, examiner A had given the first student 25, let's say out of 30, whereas the second examiner had given the same student 18, so it is positive for A. And then we go on through. Here it is 24 and 27, so it is B who has given the better score, so it's a negative sign, and we just go through them. Notice that examiner A usually gives better results than examiner B. He can give 27 compared to 19 and 25 compared to 18. But when you end up having to count up the number of the signs, you will find that 5 signs were positive and 5 signs were negative. That is to say, there is no difference between the two examiners. Whereas we are pretty sure that there is some differences in the magnitude here between the two examiners. The sign test is not able to show that. So the end result is that this is another false negative. The test results here are not significant. The S value is 5 and the number is 10, and to prove this you would need to have a critical value of 1 or less, and obviously the results are not statistically significant. By this we come to the end on this presentation on the sign test, which has some advantages like being simple, does not require normal distribution, can be used on categorical data, and some limitations like it has low power and can have high false negative results, and also does not account for the magnitude of the differences between the results of the pair of data. Assalamu alaikum.